Okay, so my final story is this upcoming mission. And this is going to happen on July 4th, so next Monday. The Juno mission, after 5 years after takeoff from Earth, it's going to arrive at Jupiter and go into orbit and orbit for the next 18 months. So just quickly, a little bit of background on this, and I stole this presentation from another person, so I'm going to go through it fairly quickly. We don't have to cover every single word, but Jupiter is one of these things that is really the crux of a lot of research. We think that it was probably the first planet formed in the solar system. Right now, it's made up of stuff very much like the sun. On the Earth, we've lost most of the history of the early days of the Earth. Not so for Jupiter. We expect it's in essentially the same state it was in 4.5 billion years ago, and it's also the largest planet in the solar system, so it's going to tell us a lot about the solar system itself. And so there's a number of measurements they're going to make. First of all, there's a lot of uncertainty right now does Jupiter have a solid core? We know that it's got a lot of gas on it. All the models say that you go down in the atmosphere, it's going to get denser and denser just from the pressure. And when they get to a certain point, the hydrogen in the atmosphere actually turns to a liquid and it becomes metallic. And that's where Jupiter's magnetic field comes from. It's the strongest magnetic field in the solar system. And so that's one model, is that it just is liquid all the way to the core, gets denser and denser. Another model is that it started by having a big rocky planet, many times larger than the Earth, and then all the gas sort of accreted subsequent to that. And so the one thing they're going to be looking for is evidence for which of those models is correct. And the best way to do that, since we can't see through 1,000 miles of atmosphere, is you keep doing these orbits, you get close to the planet, you track very accurately the motion of the spacecraft, and that motion is going to be different if there's a rocky, small core as opposed to if it's sort of a slush ball throughout most of the planet. And so over the course of these 18 months, it makes 36 orbits, and they should be able to detect enough of a signal to distinguish between those two models. They're also looking for how much water is there, and this all goes into how did the planets themselves form. And so the basic mission is 4 different things. It's how did the planet form? What is the interior structure like? How deep is the atmosphere? We don't know that yet. Is it sort of continuous through to the core? Is there other structure interior to Jupiter? And then also to study the magnetic field. So all of those things are going to be happening over the next 18 months. And this is just sort of a fact sheet for the mission. The first thing is this is the first time we've used solar power anywhere beyond the asteroid belt. All previous missions to the outer solar system used those plutonium power sources. This mission, they decided to use huge solar panels. It's from tip to tip, it's about the size of a tennis court. So it's a lot of solar panels, but they have enough energy to actually support the mission. And so we launched on August 5th of 2011. It's taken about 5 years to get there, and we'll be doing a 16-month mission once it's in orbit. So this is a diagram of what the orbit is going to look like. It's coming in this way over the North Pole, and so it'll be orbiting from pole to pole. And over the course of about 3 months, they're going to change the orbit to fairly dramatically. But to start with, it's in an orbit that takes almost 2 months to do one circuit of the planet. They're going to do 2 of those orbits, and then they adjust it into a 14-day long orbit. It gets fairly close to the cloud tops. What's really scary about this mission is the radiation field at Jupiter is something like 20 million times stronger than Earth's radiation field. And so it's a cumulative dose of radiation. Every time it flies close to the planet, it gets zapped with lots of energetic particles. The number I heard is it's the equivalent of 100 million dental x-rays over the course of the 18 months, or 16 months. So that's the basic thing. So they're going to be doing experiments to look into the atmosphere down to several hundred kilometers below the cloud tops. They'll be looking at the water and the ammonia abundances, which will tell us, again, a lot about what Jupiter is made of, how it was formed. And they'll be looking at the weather, how the atmosphere circulates, how the structure of the interior affects that, and again, looking at the interior of what's the core look like. And so this is just a view of how they, if Jupiter was a perfect sphere, it'd be this blue circle as it goes through in its orbit, but in fact it's going to be wiggling around that depending on what the internal structure is. And so they'll be able to track that. And then we'll be looking at all the details of the magnetic field. And I think what we're seeing on the lower left here is just the orbital path as it goes through the magnetic field. Okay, and Jupiter has the largest auroras in the solar system, and that's a function of having this huge magnetic field. So it's an interaction between the solar wind and the magnetic field. It brings these charged particles down in the polar regions, and so they'll be investigating the auroral activity a great deal. And so this is just a view of the spacecraft. Again, there's 3 huge solar panels. Here's a person to scale. And I should mention that this spacecraft was built here in Denver at Lockheed Martin down in Waterton Canyon. So lots of local ties to this mission. And this is just another graphic. There's a school bus, and so you can see how big those solar panels are. Okay, so let's do a quick overview of the beginning of the mission. It all started with the launch.
Control. We are now 2 hours, 32 minutes, 32 seconds away from the liftoff of the Juno spacecraft aboard an Atlas V rocket.
And again, another Denver connection. This was a United Launch
Liftoff
Alliance
is from Launch
Atlas
Complex
5,
41
so that's,
at Cape Canaveral.
ULA is headquartered
The
here in
forecast
Denver
is
as well.
essentially unchanged from what we've been watching all week. There is just a 30% chance of not meeting the launch weather criteria.
It takes everything we know to get off this planet. So while everything that NASA does and building the Juno spacecraft and exploring Jupiter is all high tech, I think a rocket launch represents the extreme of that edge.
The energy in the room on launch day is stressful, but in a good way. It's a good feeling. It's almost electric. Everybody's excited and nervous, and I've seen people before, biting their nails.
A rocket launch is one of the most amazing things to see. I mean, it's truly a cosmic event.
Go. ULA safety officer. Go. Range, weather, and final clear to launch.
Go. LC, LD, channel 1.
Go ahead.
LC, you have permission to launch.
Roger.
The launch is probably our single biggest risk in the entire mission.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of the Atlas V with Juno on a trek to Jupiter, a planetary piece of the puzzle on the beginning of our solar system.
when you see it, the first thing that you're impressed with is just the amount of energy. You feel it because the ground is shaking and you're miles away and the waves are going through the ground like an earthquake would.
Mach 1.
You're canceling gravity. Gravity's pulling you down. You've got to get to a certain speed, and then that's the escape velocity to leave the Earth.
Max Q. Boosters throttling up. We're on schedule. Engine response looks good.
You're watching something going from one planet to another.
And we have solids 1, 2, 3, 4, and 5 jettisoned. Visual indication that all solids have separated well. Current altitude is 45.8 miles. In altitude, downrange distance 69 miles. Velocity 5,413 miles per hour.
So this is looking forward.
And we have
There's
payload
the
fairing jettison.
payload fairing coming off.
And CFR jettison. We have retros and have spacecraft separation. This concludes the plus count commentary for
Juno
the
on its own.
AV-29 Juno mission.
Okay, so this was a very sort of a complicated trajectory. Here's where the spacecraft launched, did one complete circuit around the sun, sorry, I keep pushing the wrong button. Back in October of 2013, it flew past the Earth, and then that gave it a boost to actually make it all the way to Jupiter. And so here's an animation of the Earth flyby and the cruise.
Escaping the gravitational pull of Earth, Juno is still held to its trajectory by the Sun's gravity. The Juno spacecraft is carried 50 million miles into space, as far as the orbit of Mars. A burn from the main engine directs Juno back toward Earth for a final encounter with its home planet. Using Earth's gravity for energy, Juno slingshots into space, increasing its speed and receiving the boost it needs to pull away from the Sun and coast all the way to Jupiter.
Okay, and again, this is just once it gets to Jupiter, this is sort of a graphic of relative to Jupiter what the orbit is going to look like. And sort of cute, there's actually 3 little Lego figurines that were carried on board the spacecraft. And so this is Jupiter, this is Juno, who is Jupiter's wife, and this is Galileo. I'm sorry. Let me do this again. That's Galileo with his telescope. There's Jupiter and there's Juno. And so Jupiter, I won't get into all the sordid details, but he had this habit of being mischievous, shall we say, and he would shroud himself in clouds. And Juno was the only one that could see through the clouds. So I guess it's not a good idea if you're going to be up to no good to have your wife being the only one that can find out what it is you're up to. So that's the story on the Legos. And this is sort of the trailer version of what's going to happen next Monday.
The scariest thing to me about Juno are the unknowns. So much about the environment that we'll have to withstand is unknown. Nothing's really certain about what's going to happen.
It's unforgiving. It's relentless. It's spinning around so fast, its gravity is like a giant slingshot, slinging rocks, dust, electrons, whole comets. Anything that gets close to it becomes its weapon. It just so happens, deep inside this body are the secrets we're after. Secrets about our early solar system.
It's the biggest and baddest planet in the solar system, and it's got the biggest and baddest radiation and the biggest and baddest magnetic field.
The background radiation that we're exposed to on Earth is about a third of a rad. What we expect to see at Jupiter is about 20 million rad. No spacecraft has ever flown this close to Jupiter, flown this deep into the radiation belts.
So the real trick is, we gotta go in close, get the data, and get out. And the first time we go in, that's the most dangerous. We call it Jupiter orbit insertion. JOI.
Nothing's really certain about what's going to happen.
Okay, I thought you'd like that. So just in case you want to copy these down, there's a couple of websites. But again, just Google it and look for the Juno mission, and it'll lead you to the NASA websites.